Good morning, y'all. I see some people logging in on YouTube and Zoom. Welcome to SQL Saturday. We're just going to wait for some more people to log in before we start. So we'll give it a few minutes.
Was the link to PG exercises dropped everywhere?
That's a good question. I can drop it though. I'll just put it in the chat right here. I know more people as they come in, I'll have to put it in again, but okay, so YouTube and Zoom, I'm dropping the link that you can click on today to follow along with the problems that Khadisha and our guest will be doing. Did I say your name right? Ergist or Ergist?
Yep, you got it right.
Ergist. Perfect. Awesome. Okay. Give it another couple minutes and then we can probably start. Is that all right, Khadisha and Ergist?
That's cool with me.
Cool.
It's fine.
How's everybody doing today? Good?
Good.
Good. Lex is being very funny right now. Can't see Shanna, if that's how you say your name. Hi, first timer. Happy to see some first timers here. This is only our second session, so you came at a good time. And again, those on YouTube and Zoom, you can feel free to ask any questions or make any comments. We have some moderators from our community watching the chats, and they'll be happy to answer any questions or bring them to our coaches for today. Hello, hello, hello. Okay, YouTube is turning up. Okay, so I guess we can begin, y'all. Okay, so everybody, welcome to our SQL Saturday session number 2. Today, I am your host. I know I'm not Jay. So sorry to disappoint you. My name is Ugochi. I am a moderator in the All About the Data Discord community. And just a little bit about me. I am a public health associate, and I also hold a bachelor's in statistics. So I'm very interested in using my analytical skills in the public health space, specifically in population health or community health to mitigate any health disparities and to advance health equity. Our 2 coaches here for today for our SQL Saturdays, we have Khadisha and we have Ergest. So I will have them introduce themselves and we can get started.
Right, I'll go first. So my name is Khadisha. I am also a moderator in the Discord. I also work as a data and visualization analyst co-op in the telecommunications industry based out of the Atlanta metropolitan area. I also go to college. I'm also a senior and happy to be here and happy to help out.
Hello, everyone. I'm Ergist. So I've been in the data industry for the past 15 years. I've written a lot of SQL. and I've done a little bit of everything: data analysis, data science. Currently work as a data product manager, and I'm quite excited to be here. I only joined the Discord last week or a couple of days ago, something like that, and decided to just share what I've learned over the years with SQL.
Nice. Thanks
Happy to
so
be
much
here.
for your intros. Now, real quick, YouTube and Zoom, just drop a 1 in the chat if this is your first time attending SQL Saturdays with us. Just want to see who else is new. And also drop where you're from, because I know we reached internationally as well as within the States. So let us know where you're from, where you're watching from. Okay, we got some people from Nigeria, of course. Nigeria runs deep. Trinidad, thank you so much for joining. North Carolina, see you, first timer. Thanks for coming. And you guys came at a great time. This is only our second session, as I mentioned. So feel free to come every week and get some learning done. This is a great space to learn. And even the moderators and coaches that do teach with us every Saturday, it's also learning experience for them too, whether or not they have 1 year of experience or 10 years. Like, we're all here to make mistakes and teach each other and grow. All right. Okay, Kadisha, you can kick it off.
Okay, you all see the other screen?
Yes.
So I just want to give a brief introduction to the site that we're going to be using today. So we're going to be using pgexercises.com, and we're going to start with the basic exercises. And if you click the first one, we're going to start off with this question here. Well, before I start that, I just want to introduce how the site kind of runs. So basically, the database is all set up, and we're going to be utilizing 3 different tables, and they all have a relation to each other. And the relations is visualized in this, what it's called a entity relationship diagram. You'll be referring to it and referencing it pretty often, especially once we get to the joins. So just keep that in mind. Before that, I just want to show how to get a sneak peek at all of the tables. So you can do a select star from, you can start from the cd.members table. And if you run that query, you can see for yourself how the table is set up here. Do the same thing for bookings. And you can see here the bookings table. And also the same thing for facilities. Okay, so this just gives a brief intro to all the tables. As you go along, if you want to continue doing that, just see what the tables look like as you go through the questions, that's fine. First one that we're going to do is retrieve all the information from the cd.facilities table, which you just did, but I'll just do it again. So that's just retrieving all the information from the facilities table. You use a select clause to pick out the particular columns that you'd like, and this star is used to pick out all of the columns. So let's run to the next exercise. That was the first one. So this next exercise, we're going to start picking specific columns. It's a very basic exercise, as you can see. But one thing that I want y'all to focus on is writing clean SQL code. Code is read more than it's written. So you want to make sure you utilize any indentations and spaces so that it's human readable. And it also will make troubleshooting a lot easier. Another thing that I want to recommend is building your queries starting with the from clause. So I'm just going to write select there. But the question is, you want to print out all of the list of facilities and their cost to members. How would you retrieve a list with only facility names and their cost? So with that, we know that it's going to be from the facilities table. And here it's specifying particular columns to choose. So it's looking for facility names and costs. So if you look at the facilities table, at that ERD diagram I mentioned, you can pick out the name and facilities. No, sorry, member cost. All right, so when you run that, you retrieve two columns, the name and member cost from the facilities table. So fairly simple one there. We'll move on to the next exercise. This is one where we're going to get into filtering. How can you produce a list of facilities that charge a fee to members? So if you look at the facilities table, you notice that there are technically three costs. There's a member cost, a guest cost, and a monthly maintenance cost. So we can assume that the fee to members is attributing to the member cost. And again, I'm going to build a query starting with the from clause. So from cd.facilities. And here we're going to specify a condition where member cost would be above 0. Because if it's above 0, then that pretty much says it charges a fee to members. And looks like they're not asking for a particular column, so we're just going to do a select star again. And when you run that, you do get your answer here. These are all the results where everyone's actually charged a member cost above 0. On to the next exercise. How can you produce a list of facilities that charge a fee to members that is less than 1/50th of the monthly maintenance cost? Return the facility ID, facility name, member cost, and monthly maintenance of the facility in question. All right, so this one is a little step up, a little uptick in difficulty, but here we're going to use another where condition, but that 1/50th of monthly maintenance cost. There's multiple ways you can do that, but let me just start off by building the query from the from clause. So from cd.facilities, it's asking for the name. Well, it's asking for facility ID, facility name, which you can do by name, and then the member cost. And lastly, the monthly maintenance. Now, the condition that it wants is pretty much where member costs is less than 1/50th of the monthly maintenance, and that they charge a fee to members. So let's start off with the first one, where member cost is less than 1/50th of the monthly maintenance cost. So with that, you can actually use a calculator and convert 1/50 to, that'll be 0.02. And that you will multiply by the monthly maintenance. Now it's also asking for another condition. And here we're going to use a logical operator called AND. you use and where the result has to satisfy both conditions. So both have to be true. So here, if you recall from the previous exercise where you wanted to get the results where a fee is charged to members. So basically, again, that is where the member cost is above 0. And then you run the query. Oh. Oh, I spelled member cost wrong. That's not going. I think I spelled maintenance wrong.
That same thing happened to me last time when I first did this too.
Yeah. Let's see what's going on here. This is still not running. Let's see. All right, looks like I'm spelling it wrong somewhere. I think I spelled it wrong over here too. All right, there we go. And that is your answer there. Are there any questions like populating the chat or something I need to take a pause for? Migochi.
No questions in the chat so far.
All right, good to go. So, all right, next one. We are going to move on to some string searches. How can you produce a list of all facilities with the word tennis in their name? Okay, so let me start off with building the query from the from clause. From cd.facilities. And we're going to select all columns. And we're going to have a condition. So we're going to use the where clause again. And the condition is going to be in the name. So when you want to search for a particular result and you want to say use the word tennis in there, what you would use is the like operator, and you will actually use a wildcard. And so how it would work is you would do name like, you would do you do a single quotation, wildcard, tennis, another wildcard, and then another single quote. So what happens here is that this wildcard represents any number of characters on both sides. So as you can see, this encompasses tennis court 1, tennis court 2, and table tennis. So it's very flexible, as you can see, and it's fairly simple. And we'll move on to the next exercise. How can you retrieve the details of facilities with ID 1 and 5? Try to do it without using the OR operator. Okay, so let me start building the query to do from cd.facilities again. And it looks like they want all columns. And we're going to do another condition. And so here it says, try not to use the OR operator. So unlike and with OR, results can satisfy either condition. And so another alternative of using multiple ORs is using what's called the AND operator. But the AND operator is basically saying that, select all results or select all columns where the facility ID is either 1 or 5. And so this is a quicker, more simpler option than doing where facility ID equals 1 or facility ID equals 5. And that is your answer there. Then move on to the next exercise. So in this exercise, we're going to introduce a case when. The question is, how can you produce a list of facilities with each labeled as cheap or expensive, depending on if their monthly maintenance cost is more than $100? Return the name and monthly maintenance of the facilities in question. Okay, so here, it's going to be a bit different. If you notice, cheap and expensive, that is not in the tables. So that's something that we have to create. And so we'd use a case when. And this is a syntax that you see on the left side. Basically, case when allows you to create buckets from your data based off of series of if-then statements. The buckets that we're going to use is cheap and expensive. And the two conditions will be whether they're greater or less than $100. So let's build out the query here. And we're going to do name, then we're going to immediately get into the case whens. First condition is going to be monthly maintenance. First one we're going to do is less than 100. So when monthly maintenance is less than 100, then we're going to label that as cheap. And then the next condition will be we're going to do greater or equal to 100, and we're going to label that as expensive. Now, you can also do an else. That's a good way of actually troubleshooting sometimes. But then you can do end as cost, and this cost will be the label of the new column. And we're going to do that from cd.facilities. Okay, so just to review what we did here, we took the monthly maintenance column and basically made two buckets of cheap and expensive based off of whether something was greater than $100 or, sorry, greater or less than $100 and less than $100. And this is the result that we get.
Awesome. Khadisha, real quick, someone had asked if the tennis, like when you put that in the search or when you use the wildcard, is it case sensitive?
Oh no, let's see. I guess so. Yeah, it looks case sensitive. At least in PostgreSQL, it looks case sensitive.
Right. Okay. I know in some other like database systems, I think it's not case sensitive, but I guess in PostgreSQL, it's case sensitive.
Yeah, it looks like it. All right, moving on to the next one. All right, so just to kind of harp on what Ugochi just mentioned, the meat and potatoes of a lot of SQL is pretty universal across all different types of servers, but there are definitely areas where there's differences based off of what you're using. So dates is one of those where it can be different across other or all servers. But this question is, how can you produce a list of members who joined after the start date of September 2021? Return the member ID, surname, first name, and join date of the members in that position. So here, let me just start off with building the query. It's going to start off from the from clause. So from cd.members, we're going to choose the member ID, surname, first name, and then the join date. And so here, the condition is basically whoever joined after September 2021. And so what you can do is do a greater than, and in single quotes, you can put 2021-09-01. So this will return the member ID, surname, first name, and the join date from cd.members where the join date is greater than September 1st, 2021. Now in PostgreSQL, just doing the single quotations with this timestamp, it converts it to September 9th, 00000. So as you can see, the whole timestamp is the date and then the time. Just in Postgres, this just works. It just automatically casts it or converts a data from one type to another as the 1st of September with a 000000 timestamp. And also for those who are following along, if you look towards the bottom, they have a slight explanation of everything. This site is mostly good for practice, so explanations might not be that great, but they do have explanations of why the answers are what they are. All right, next question. Okay, how can you produce an ordered list of the first 10 surnames of the members table? Okay, so here we're going to introduce something new called a select distinct. Select distinct is used to select distinct records. So I will start there. And so the select distinct is asking for the top 10 surnames. So we're just going to select distinct on the surname. And then we're going to do from cd.members. Now it's asking for the first 10 surnames too. But before that, it's an ordered list. Okay, so we want an ordered list. And so with that, we're going to be using what's called an order by. This sorts the results by an intended column. It's automatically set to ascending, but you can also do descending by denoting either DESC or ASC. So if we want the ordered list of the top 10 surnames, we're going to order by surname, and we actually want it ascending. So you can either just do order by surname, or you can put ascending. Then it asks for the first 10 surnames. And so with that, we're going to introduce limit, which does what it says. It limits the amount of rows that's returned. And there you get the ordered list that's in alphabetical order, and it's the top 10. All right, moving on to the next one. Okay, so here is a gentle intro to joins. I'm not going to go really, it's asking for a combined list of all surnames and all facility names. It's a very interesting ask, but as you can see in the expected results, it's asking for one column that's a combination of surnames and facility names. So there's all types of joins. This one that we're going to actually use is union. Union stacks all the tables on top of each other, which is exactly what we're going to do with this. We're going to stack the surnames and facility names on top of each other. So what we're going to do is we're actually going to have two selects, but I'm going to select from cd.members first. I'm going to select the surname. Then we're going to union, do another select statement from cd.facilities. And there we're going to select name. And so that gives us the very interesting combined list or stacked list of name and surnames from both tables. If anyone was doing the taxi challenge, union is actually what you would have done to combine all of those yearly tables. So it should be a little familiar for those who are doing that. Okay, last two questions here. How would you get the sign up date of your last member? Okay, you would like to get the sign up date of your last member. How would you retrieve this information? Okay, here, so we're going to introduce some aggregate functions. There's a lot of them. What we're going to use here today is the max function because it wants the last sign up date. So let's start building the query. We're going to do from cd.members. And from cd.members, what we want is the max join date. So that gives you the most recent date here of those who joined, or of the member who joined. One thing about aggregates, you cannot use them in the where clause. It would have to be accompanied with it having, or you'd have to use an advanced function. Depending on what you need to do, you'd have to probably use an advanced function like a subquery CTE, depending on what you need to get. That'll be covered more in detail later on, but I just want to mention that so you can keep that in your head. And our very last basic question is, how would you get the first and last name of the last members who signed up, not just the date? So with this, there are at least two ways you can do it. There's a basic way and a more advanced way. You can actually use a subquery if you'd like. I will introduce the basic way of doing it. And the basic way just uses an order by and a limit. So let me just start by from the cd.members table, selecting the first name, surname, and then the join date. And here, since it wants the person who signed up last, we're going to order by join date. We're going to do descending to get the latest one. And then to get the top one, we're just going to limit by 1. And that gives you the very last member who signed up, the most recent member who signed up. All right, so that is all that I have from my end. Are there any questions?
Thanks, Kadisha. Let's see. Are there any questions on YouTube regarding this problem or any of the problems that Kadisha just did? What did I see? I swear, when I did this problem, it was just as simple as putting limit 1, and I was so lost. Like, that was like the one part that I missed, and I was like, how do I get just this one? And then I figured it out like way later. It was that simple.
I like to make things hard on myself, so I actually did the subquery first, because like you can do the hint.
Do that too.
Yeah, you hit the hint and it says probably you do the subquery. So
Mhm.
I made life tough for myself and just did that.
Right. Okay. Let's see. I don't think there are any questions that haven't been answered in the chat already. So I think we can move forward.
Can you stop sharing my screen then?
Awesome. And then Ergus, you have the floor.
Okay, can everybody see my screen?
Not yet. Okay, we're good.
Yes?
Yep.
We're good? Okay, well, hello, everybody. Today we're going to be talking about, started to talk about joins. And I want to make sure that people understand what joins do and why they're used, why they're so important in SQL. I know I've seen some messages on on Discord where people are, scared of joins. You don't have to be scared. This stuff is super easy. This is very basic SQL functionality. The way you put tables in a database, just like we have here, you split them up like this because you want to reduce redundancy, right? So what we could have done here is we could have put everything about this tennis facilities or this facilities and members, we could put everything in a single table, right? So one row for every facility, for every booking, for every member. It would be a giant table and you can run, just selects and filters on that table. But when you store this information in the database, you have to keep copying the members' names multiple times, right? For every booking, for every facility, you have to have a separate row, just like you would say in Excel. In databases, what we do is we normalize our data. So by normalize, we mean we kind of split out the stuff that repeats and put it into a separate table so that there's like only one row per member. We want to make sure we have a table of just members that has one row per member, so there's no redundancy. And then in the bookings table, we have this member ID column that is the only column that repeats for every row, for every member that has a booking, that member ID will repeat. By only keeping a single, in this case, it's a number, but by only keeping a single column in the bookings table, we ensure that we store the least amount of information while still keeping the ability to get all the members' information through a lookup. So a join is basically a lookup. Sorry, am I on the first? Okay. So the idea is when you join two tables, you're basically doing a lookup from table 1 into table 2. You take the column that is known as the foreign key. In this case, member ID is the foreign key in the bookings table because it belongs to another table, to members. And then the primary key is the facility ID here. This table actually doesn't have a primary key, so it has a combination of facility ID and member ID. But the idea is that if the bookings table has a member ID, we know that we can look up all the members' information by doing a join. And the syntax is very simple. I know you've probably seen the old style syntax. In fact, if you look at the solution here, they actually suggest this old style syntax where you say from table 1, comma, table 2, and then you do your join in the where clause. Don't use that. That is very confusing. The standard way of joining tables is by using the explicit inner join or a left outer join in case you're doing an outer join. So you're just selecting T1.column1 from table 1 as T1. So we have to use these aliases for the tables, right? The idea is like what I could have done here is I could have said select table 1.column1 and not had to use an alias. But sometimes these table names are really, really long and your query will look very messy if you have to repeat table 1.column1, table 1.column2, table 1.column3. So what we typically do to make life easier for ourselves, we put an alias on the table name, an alias that has like 1, 2, or 3 characters. And we use that alias everywhere in this query. So then we would say t1.column1, t1.column2, t1.column3. Just makes the query a lot easier to understand, a lot easier to read. I know that I'm also sharing the solution here. I know Kadisha actually typed up all the queries. I'll probably not do that because these are kind of complex queries, but I'll explain them as I go. I want to make sure that people understand what joins are and how they work. There are several types of joins, but these are the 3 most common ones. There's the inner join, which we'll see an example of it, but I'll explain it here in the presentation. Actually, why don't I switch to the slideshow here? Okay, so the inner join will only show the matching rows from both tables. So as we saw in our example here, we have members and we have bookings. If a member does not have a booking, for example, when you inner join the 2 tables, that member ID will not show up in your query. Now, if you only want members that have bookings, that is fine. But if you want to show all members, regardless of whether or not they have a booking, you would use you would use an outer join, and there's 2 types, left and right. Nobody uses right, so only use left. Left outer join is the 99.99% of the time you would use a left outer join. So it shows all the rows from the left table, and we'll see an example here in just a bit, and all the rows and only the matching rows on the right table, and the ones that don't match you will see a null. The third type of join is a self join. We'll see an example of that in just a little bit. A self join is usually used if a table has kind of a parent-child relationship. In this case, the members have like a referred by relationship. You could store that into a separate table and kind of use a join, but it is the exact same table because they are also members, right? So we want to reduce redundancy. So what we do is we add a column that points, it's basically like a self-reference. It references back to itself. Let's take a look at this simple example of how joins work. So in the left table, we have a shopping list of what we're going to buy and the quantity that we want from the store. And on the right table, we have the store information. Like the store has, we want bread, cheese, eggs, milk, and olive oil. The store has all the stuff that it has also cookies and fish, which we don't care about, we're not looking. So finally, when we buy everything, if we're using an inner join, the bread will match with the bread, the eggs will match with the eggs, milk with the milk, and olive oil will match with olive oil. The store does not have any cheese, and so cheese will not show up on our receipt. Does that make sense? This is how the inner join works. It actually removes all the rows that do not match. I want to pause there for a second, see if there's any questions. These are slightly more advanced concepts.
There's one question, or really 2, asked by Jalen. So they asked, can you please explain the CD dot and BD dot? I know you're not really there yet, back to the PG exercises, but when you get back there, you can definitely explain at that point.
Okay, yeah, that's basically the reason why we have a CD dot, right, in our database. Yeah, okay, I'll explain that when we get there. I want to make sure that folks understand the join business here. And here's the same example using a left join. So in this case, again, everything will match, but because there is no cheese, it will not match, but it will still show up. Cheese will show up, but we'll have a null for quantity and null for total. This is the idea. So if I wanted to see everything in my shopping list, and then I wanted to see everything that I bought and the things that I didn't buy, I want to see like a null or an empty column, then I would use a left join. This is used a lot in cases where you have, for example, transactional data from your transactional systems that you're working with. It could be healthcare data, it could be website logs data, and you want to be able to see all the transactions, and for example, you want to see products that are currently valid and products that are not valid. So that's where you would use a left join, because an inner join, as we see here, will remove the columns that don't match. Okay, this should have been join introduction. Lots of queries introduction. And let me then explain the self join. So the self join is basically a table joined with itself twice. But what we're doing is we're using this recommended by column, which is a key. It's basically a member ID, right? But it's used. So for example, if I was referred by Ugochi, for example, there would be a row here in the members for Ugochi with her ID. And then in my row, I'll also have a row. Her recommended by would be 0 or null. My recommended by would be her ID. That way, if we wanted to see who referred whom, then we would be able to join the table with itself and be able to see that relationship. Okay, so there was a question about why we're using cd.members. In databases, you have 3 levels of like breaking things logically in a database. You have a database name, a schema name, and a table name. Now, these 3 are used to kind of group things together into logical pieces. So for example, if you had an app and a website, you would have a database for the app and a database for the website. And that would be, for example, the app database and the website database. Inside these databases, there are what's known as schemas. Schemas are a way of grouping multiple tables that all have the same type of functionality. So for example, for bookings, you would have an app.bookings schema and an app.booking and a website.bookings schema on the other database. And then the table names are basically like you have something that looks like, I'm going to type this up here. That doesn't make any sense, but it'll be when you select the table, you would say select from database name dot schema name dot table name. This is like full referential for any sort of database, whether you're using Postgres, whether you're using MySQL or SQL Server. They all have the same way of organizing objects in a database. There's always a database name, which is where all these tables are stored. Within the database, there are schemas. So maybe you could have a schema that's public and a schema that's private. And you can limit, this is also done to limit who sees what. So if you're a particular type of user and you are not allowed to see private data, you will only be able to see public data. And then the tables are then come after the schema. Does that answer the question?
Yes, it does. Thank you so much, Marcus.
Okay, so let's take a look at this exercise that introduces us to joins. We are asked to produce a list of the start times for bookings by members named David Farrell or Farrell. Okay, so we want to get the start time. So where does that live? Okay, if we take a look here, the start time lives in the bookings table. Okay, but the bookings table only has a member ID, so we can't match the name to the member ID, which means we have to then join the members table on the member ID. So we can see here from cd.bookings as B, inner join cd.members as M on. So again, the syntax that I explained earlier, inner join table one as T1 on table two dot as T2 on b.member ID equals m.member ID. So this allows us to then look up the name of the person and then find the start time for Mr. David Farrell. And then here we do.
Sorry to interrupt.
Yeah.
Making the that screen a little bigger so that people can see the code a little more.
Oh, the code one. So zoom in a bit.
Yeah, you can either do that or make that side of the screen like larger than the other side. Yeah.
Does that work?
That should hopefully someone that asked. Awesome. Yeah, that works for them. Cool.
Okay. So we run the query and we get these are all the start times. So this person has a 9 o'clock, 5:30, 1:30, and so on. You can see that these are unordered. This is an important concept in SQL. You are not guaranteed a sort order. When you pull data from a table, you are never guaranteed a particular sort order because the database can store it in whatever way it feels is best for the database. If you as the analyst want the data to be sorted a certain way, you have to specifically say order by, and then put the columns that you want to sort it by. In this case, we could have sorted by the start time. So that is the basic introduction to a join. Let's move on to the next exercise here. Okay, so work out the start times. So how can you produce a list of start times and the name of the facility, but we only want tennis courts for a particular date. So in this case, we're now looking into the facilities table. So you can see the bookings table it sort of brings together members and facilities, right? So it's got one row per facility ID per member ID, and that's a booking. It says Mr. So-and-so has a booking on this date on this facility, right? So you have one row that specifies that relationship. In this case, we're not worrying so much with the members. We're looking into the facilities table here. One thing that I want to mention with the entity relationship diagrams, which Kadisha explained early on, is that a relationship is either one-to-one or one-to-many. So the idea is one-to-one means one row on the left table can only match to one row on the right table, and one-to-many in this case means that one particular booking, for example, could only be at a particular facility. Bookings of facilities could be one-to-one. I don't know exactly here. They don't explain this diagram, but it kind of makes sense that you want to book a particular facility. You only have one booking for a facility, whereas the booking to member is one-to-many. One member could have multiple bookings. I hope that makes sense. Okay, in this case, we are starting with bookings. We want the start time and the facility name. We are doing, again, an inner join. And we want to specifically say, we want to join on facilities. We can see the diagram here that the facility ID in the bookings table matches the facility ID in the facilities table. So that tells us we can join on that column. And we want to filter only the bookings that were on September 21st, 2012. The way you do that with dates, as Kadisha also mentioned, is you put the date in as this formatted string, which is year, month, date. And we're saying start time is greater than or equals to 2012/9/21. This roughly will be midnight 0000, basically the the very first second of that date. And we want everything that ends before the next day. So this ensures us, see there's no equals here. This ensures us that it's only bookings for 9/21. And since we only want tennis courts, we can say facility.name like tennis %. This goes back to what Lisa was mentioning, which is this like operator using a wildcard, meaning I don't exactly know how many tennis courts there are, but I don't care as long as they say they have a pattern that starts with tennis and then something after. And then here we're sorting by the start time. So we can run the query and we get the correct results. Okay, I'll pause there for a second, see if there's any questions before we dive into left joins.
Not seeing any questions in the Zoom. I think all the questions are handled on YouTube as well, so you're good.
Okay, moving on to the next exercise. Okay, here we now have an example of what I mentioned earlier, which is this self-join. The self-join is exactly what it sounds like. You're basically joining a table with itself. And we only want people that have recommended somebody else. And we want to make sure there are no duplicates. Because we only want members that have recommended another member, that means we can do an inner join here. So we basically just, now here this is something that's really important to mention. Since we're using the same table in a SQL query, you cannot use the same column name multiple times. If I were to just say, first name and surname, and I do run, it'll say column reference is ambiguous. You'll see this in multiple databases. You'll see, ambiguous, and then the column name. What that means is that that column name exists in both tables, and SQL doesn't know which one to pick. So you have to tell it which one you want. Now, they could both be the same. In this case, they're not the same because the first name from the second table is the member that was referred, and then the first name from the first table is the person that did the referring. So in this case, we only want those that referred or recommended somebody else. Here's where these aliases come in handy. I forgot to say as. You can actually omit as. I'm just used to omitting it. So here's from cd.members as original. So these are the folks that did the recommendation. Inner join again itself as recommendation so the original.member ID equals recommendation.recommended by, right? So as I said earlier, if Gochi had recommended me, there would be a row on the table with her member ID, and then my member ID there would be a row in the table with my member ID and her member ID in my recommended by. So when I join this table to itself, I get both my name and her name. In this case, I need specifically original dot first name and original dot surname. And we want the data to be sorted by first name, by last name, first name. Okay, so this is basically a self-join. You'll see this in cases where, say, there's like employer and manager type of relationship. So a table would be like just an employees table, and then there would be an employee ID. Then somewhere down there will be a column that says manager ID, which is basically the employee ID of the manager. And this is how you basically create this like parent-child relationship. And you can actually go multiple levels on this. This is a way to like store data that looks like a tree in SQL, and you can get pretty fancy with this stuff. And each time that you want to go a level, you have to keep joining the table with itself. This is only going down one level, but in cases when this relationship repeats, you might have to join multiple times. This is an example. So this is used in cases, for example, if you have page view data on a website, and you want to know which page did they come from previously, and you want to kind of connect their entire customer journey, right? So you have a column that says this is the referring URL, and this is the previous page URL. So you can sort of like each page that you click on would have the URL that it came from and its own URL. And so you can kind of piece together the journey going back. It's sort of like a linked list of multiple references. Okay, I'm going to move on to the next exercise here. Okay, so this is basically the same question, except now that we're being asked to show both the member's name and the member's and the recommended member's name. In this case, we're actually being asked, including the individual that referred them. Okay, this is our first introduction to a left outer join. In this case, what we want to do is we want to show all the members, regardless of whether or not they referred someone. And on the right-hand side here, on the recommended first name, recommended surname, we want to see everyone that they recommended, regardless of whether that person exists or not. So in this case, we want to use a left outer join. It works just like the inner join, but it has this powerful feature that it will show all the rows from what is considered to be the left table, as we saw in my presentation, and only the rows on the right table that match will have data, and the rows that don't match will have null. In this case, nulls are shown as blank. So in this case, again, here the aliases are super important, right? Because they actually mean different things, even though it's first name, surname, first name, surname. The members.firstname means everybody that exists in the members table, and then the recommended.firstname, only the people from the second table that match. And that is an example of a left join. Very simple, left outer join. So members as rex, as mems, on rex.member ID, mems.recommended by, and then we are sorting. Okay, that was an example of a left join. I'll pause there and see if there are any questions. We have an example here of more than one table join. I want to cover that before we dive into some of the subqueries stuff. So as you can see, in this case, we want to show a list of all the members that who have ever used a tennis court, include also the name of the court. So we are joining members to bookings, or bookings to members. And then we also joining in the facilities, because we want to grab the name of the facility. In this case, we want to only show tennis courts. So we start with members. Why do we start with members? We want a list of all the members, so we don't care whether or not, well, actually we do care that they have a booking. So we start with members. We join members to bookings. That, again, we've seen that before, just a member ID, members to member ID equals bookings to member ID. Now we join bookings to facilities. Okay, so we're basically traversing this whole chain. We're going from members to bookings to facilities. And you can chain bookings together in SQL. They don't have to be one after the other. I could add a join here and join back to members, for example. This will keep the database will not complain. But we have to be sure that the tables that we're choosing to join on all have, there's no missing data, that there's no messy data, and so on and so forth. In this case, this is a very clean database. So we can join members to bookings, and we join facilities to bookings, bk.facility ID equals facilities.facility ID. And here we just say facility.name like tennis. Okay, let me pause there before we dive into the subqueries. See if there's any questions.
Anyone have any questions?
I do have one question.
Mhm.
So when you're performing joins and whatnot, what are some like common rookie mistakes or just anything that
Mhm.
just simple mistakes that you can make?
Yeah, that's a great question. So one of the most common mistakes that you will see in a join is what I call the fake left join. Why is it fake? Okay, let me see if I can explain it here with an example. So very, very cool here. We want to show all the members so that you're fully intending to do a left outer join, right? You want all the rows from the left table and only the rows in the right table that match. However, for whatever reason, you want to filter the rows on the right table. So very, let's say, I guess naively, you might say something like, Rex dot name like Tim. Well, let's just say, for an example, this to you will look very normal to you. However, when you execute this query, your database will completely ignore your left join and actually perform an inner join. This is a very common mistake when you do left joins. That's why I call it the fake left join, because you put in a left join, you think you're doing a left join, but because you are doing this, you are taking the left table and putting the condition here in the where clause, SQL will ignore the left join and do an inner join. So how do you deal with this? The way that you normally deal with this is you take this from here and you put it in a join condition like that. That may look strange, but this is actually very normal to see.
That makes total sense. Thank you so much.
Does that make sense?
It does.
Yeah. Now you'll perform an actual left join. Now, since I got on this example, the only case where this is okay is if I wanted to see only the members that have not referred anybody, maybe because I want to send a marketing piece to them, then I can say with rex.name is null, and I can run that query. Okay, this is going to, it's going to be first name, my bad. Okay, the query now is going to run, and it's only going to give me these folks here, Tim and Darren, that have not referred anybody. This is also okay. This is still performing a left join, but it's now only limiting people that don't have anybody referred. This is a great example to see if for whatever reason you have missing data on the right table and you want to see what are those rows that are missing. This is a very common pattern to use. So you do the left join, and then you see where second table dot any column, could have been first name, could have been member ID, is null. This will give you only those that. Now you can also do the opposite here, and you can say where this is not null, This is basically doing an inner join. This will give you only the people that do have somebody referred. Okay, does that make sense? Since I kind of went a little bit on a tangent there, but I think this is it's a very good question, Jalen, because this is something that people get hung up on a lot. Any other questions before we dive into the world of subqueries?
You're good.
Okay. I will jump back into the presentation. Oops, that's not what I want to do. Share, hit slideshow. Okay. I don't use subqueries, or rather I use subqueries very sparingly. Why is that? I love CTEs. Now, CTEs are common table expressions, but I'll cover them in a little bit. The way that I use subqueries sometimes is, say I write this like super complex query here, and it's giving me all these rows, and I only want to see some of those rows, and I cannot filter on the where condition inside the query. I'm doing some calculation, and I want to filter based on that calculation. In this case, for example, maybe I'm doing this calculation on, maybe I'm doing a calculation on column 1 here. And I want to filter by that calculation. So what I would do is I put like a wrapper around this query, select star from open parentheses, my whole query, close parentheses, have to say as something, because otherwise your database will complain. And then you put in the where clause. Now I know that's not how people explain subqueries. Subqueries were very popular before CTEs were introduced. And unfortunately, so CTEs were introduced into the SQL standard in 1999. However, a lot of databases took a very long time to actually implement them, to actually make them available for people to use them. So what you had to do before CTEs were introduced, you had to use subqueries. What I don't like about subqueries is that you can nest them so many levels deep, and you basically lose track of where things are coming from. You can no longer read the query. It can get you the right result, but your query is no longer readable. There are some databases like MySQL, which waited until, I don't know, 2015 or much later to actually introduce CTEs. I think it's MySQL version 8.0 and above that has CTEs. Prior to that, only has subqueries. So if you're stuck on one of those at work, because some of these systems are really old, well, I feel sorry for you, because I'm not a fan of subqueries. Yes, you can use them to get things going pretty quickly, but I'm not a fan. So I will explain CTEs. Then you can also use that to understand how subqueries work. So what a CTE is, CTE, or a common table expression, it's basically like a view or a temp table where the scope of it is limited to your current query. So basically, it's not, if another query is running at the same time in your database, it cannot see your CTE. Only the query that you're running can see that CTE at that time. Okay, so that means that you can use them to kind of break up a super complex query into multiple smaller queries. That's how I use them. So how do they work? They use this like with keyword. So you say with, and then you give it a name, CTE name, as, and then you see the brackets. So the brackets work kind of like a subquery. So in this case, I'm doing select column 1 from table 1, whatever, some condition inside here. And now I can use this CTE name just like a table. I can do select star from CTE name or column 1 equals X. So that's the reason why I like them, because I can define some aggregation, or I could define some join in the subquery. In the CTE, and then I can refer that CTE later on. Then I can join that CTE just as if it was another table. I can join to it. I can aggregate it. I can treat it pretty much like a view or a table in the database. And what this also does, like if you're reading this query, you read it top to bottom. If you're reading a subquery, you first have to find like the innermost subquery and work your way out. If you're reading CTEs, you basically read it top to bottom. So you first see, okay, what is he doing here? Okay, he's defining this aggregate just like this. Okay, great, I get it. Now he's using that aggregate to do this other thing. Okay, now I see how he broke up this complex query into these multiple pieces. Does that make sense? We'll go through an example in a little bit. Okay, so where did this is another multiple join. This is another multiple join. I want to spend some time with CTEs. Okay, so here's an example of using a subquery. This is basically asking us to do the same thing that we did earlier, that we did with a self join, but it's telling us do it without using the join, do it by using a subquery. Get all the members and anybody that they referred without using any joins. So I get the member.first name, and this operator here, the two parallel bars, is like a concatenation. It just joins strings together. So it says, take the first name, add a space, add the last name as the member, and then inside that select, I put another select from cd.member, and here's where the join happens. Okay, so recommendation.member ID equals member.recommended by from cd.members. So like if you were to look at this just as a subquery, this is like very weird because I'm selecting this stuff. Okay, I get the member's name. Now I'm diving into another layer of the query. So I have to now remember what I'm doing from the previous query, like in my mind, if I'm trying to understand this query. And it's selecting for members, and then the subquery is selecting all the members for that member. One of the things that this subquery does is it executes multiple times in some databases for every member. So for me, for example, it'll go through and find everybody that I recommended and list all of them. And then for the next row, again, run through the table, get everybody that I recommended. So in some databases, this can actually be inefficient and slow. I think MySQL, in some versions of it, this could be very inefficient, which is part of the reason why I don't like them. But this is an example of using using a subquery. Here we'll see how CTEs work. Okay, in this case, this is like a messy logic query that looks at, we want to produce a list of bookings on the day of September 14, 2012, which will cost the member or the guest more than $30. Remember that the guests have different costs to members, and the listed costs are different for every half-hour slot. So this is a very complex calculation. So the way that I would solve this with a CTE, which I have explained here, I don't know if you can see the whole thing. Yes, their solution uses subquery. My solution uses a CTE. So with bookings, so I'm calling my CTE bookings as, and then in here I'm saying get all the members, first name and last name, add the facility name, and then I'm doing a calculation for the cost. So the cost, if the member ID is 0, if they're a guest, then the cost is basically slots times the guest cost. And if they are a member, the cost is member cost times the slots, right? So this is where we have this case statement here. Then I join the bookings and the facilities, where booking dot start time is September 14th and it ends before September 15th. So I could run, if I were in a database, I could highlight this and I could just run this inner query and I can check myself. I can basically say, okay, am I seeing everybody that I want to see? If everything looks good, then I can select from this CTE, select member facility cost from bookings where cost is greater than 30. Great, so now you read this query top to bottom. You see that I define the bookings in here and the cost based on whether they are a guest or a member. And outside of the CTE, I can treat it just like as if it was a table. I could call it bookings. Now, one thing to mention here, this is not cd.bookings. No, that would be wrong. This cd.bookings would be as if I was calling from the table. No, so normally what I do is I just say underscore CTE there so that I don't confuse myself. And I can run this and this will work. Of course, the results are now hidden because I stretched this too much. But this is the magic of CTEs. They allow you to break your query down into multiple steps. So get me my first step, get all the bookings for members and for guests, calculate their cost based on whether they're a member or a guest, filter down to only September 14th. Get me, of course, the facility name, the member, and the cost. And now I can do whatever I want with that data. I can filter it down to 30. I could join it again with another table. I can do more calculations. I can actually define another CTE. I can do bookings CTE 2, basically use this data, and I can, in a way, kind of chain this CTEs one after another and solve a very complex query in multiple steps, as opposed to one single giant step. Now, no, this is like getting into kind of like advanced how to solve complex queries. I know this is not for everyone, but I wanted to, share this as an example so that folks who are perhaps at that level can learn a little bit. Ugochi, are there any questions? Did I lose anybody? Did I lose everybody?
I hope we're all still here. That was really great. That was a great explanation of CTEs because I'm even new to that myself. But there's no questions in the chat from what I.
We're almost up at time, so I don't know if there was anybody else. I think it was just the two of us that was presenting. So I managed to stay on time. Look at that. Awesome. I'm open for questions. Any question that you might have, anything that kind of bugs you, or it could be like, don't be deterred by the fact that, I talked about an advanced topic. You can ask pretty much any question. Like Jalen's question was great. Go ahead, Jalen.
Yes, so I do have one question. So I am applying for roles that requires like a basic fundamental of SQL. So with CTEs, I'm just curious, do you think they will probably ask about your knowledge of CTEs, or is it just more of a preferential type of thing?
So CTEs are more advanced.
Okay.
If you know basic filtering, what Khadisha covered,
Mm-hmm.
And if you know how joins work, which is the first part of my presentation, that should be enough to get you through the interview process.
Oh,
If you become much more of a data analyst later on, you'll probably learn CTEs, because I've seen some queries that go up, 300, 500 lines
oh, wow.
of code. Part of that is because you're selecting so many columns from so many tables, but also part of it is you're doing a lot of different operations to kind of like shape data up to the final result.
Oh, perfect. Thank you so much. I feel much more confident now.
Yeah,
Thank you
yeah.
so much.
If you knew CTEs, that would be an added bonus. But yeah, if you just understand the basics, that should get you most of the way there.
Great. Thank you so much,
Sure.
everyone.
Are there any other questions? Any other brave souls?
Yes, there's a question actually in the YouTube chat from what I saw. Someone had asked for the dates. Why can't we simply state start time equals date, for example, and leave it at that? I'm not sure which question that's in referring to.
See if I can
Oh, I
see
think
the
it's probably the
question.
one that you're doing right now, maybe.
Oh, I see a question. Is width enough for multiple CTEs? Yeah, one width is enough for multiple CTEs. Yes. Okay, for the dates, why can't we simply say start time equals? The reason for that, S. Kabara 4111, is that sometimes the dates are stored as a timestamp, which means you get the date, you get the time, you get the minute, the second, the millisecond, and everything. And when you say equals, you will not get a match, because it will basically equal to the midnight. So what you can do if you want to do equals is you can apply a date function. You can say start date equals cast, and then.
Are you still sharing your screen?
Oh, I'm not sharing my screen.
Okay.
I'm typing into the
On the
chat.
chat. Okay, great.
Start time as date. When you do a cast, you're basically converting that timestamp into just the date. You can basically, you're truncating all the time information. Then you can do an equals. Does that make sense? Does that answer your question? Let's see, is there any other questions? Okay, zoom into my screen. Okay, most databases don't allow you to do many-to-many directly. Yep, that's right. Okay, cool. I don't see any other questions. I should probably continue to share my screen because there was some additional information in the presentation. Give me 1 second here. Let me pull this up again. So, yeah, we would really appreciate it if you would take our survey and let us know how we're doing. Like what she said, this is our second SQL Saturday, so any feedback would be great. And then I think the link will be dropped somewhere.
Yes,
Bochi,
in both
you've got
chats.
that covered. Okay. And then here's how you can reach any one of us. I'm available on Twitter at ErgistX or LinkedIn. Kadisha is also available on Twitter at Kadisha12. She's also listed her portfolio on GitHub. And then Ugochi is also on Twitter.
Yep, that's me.
Uwe, I don't know
Yeah,
how you
those
would
are my
say
initials. This is my initials and my last name. So it's pretty
Okay.
simple. But thanks
Got
so
it.
much. Thanks so much for your lessons today. To the coaches, give it up for the coaches, everybody. They were such a great help today. Like we said, our SQL Saturdays are used as learning sessions. So we're here to learn together and we're here to ask questions. You can come off mute if you're on Zoom with us. and you can ask your questions and get those solved by our expert coaches that we have. So lovely job today.
Kenisha's like, I'm no expert.
Thank you, Jalen. Thank you for asking questions too. You're awesome.
Yeah, thank you, Jalen. Those were great questions.
Yes. And thank you to everyone in the YouTube as well. And if the survey is in the chat on the YouTube, so definitely take our survey and give us any feedback that you have. Right. Y'all have an amazing day. Thanks so much. We'll see you next week.